6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. 7.6 million pounds of thrust, and it has cleared the tower.
Prepare yourself for a world of science. This is Science.
Good morning, everybody. Conley here with the Science Nights in the morning. I have two nights assembled this morning. We have all the way from down under Dr. Sean Graham and Dr. Anirban Bhattacharjee here in the studio. What's up, Anirban? How are you doing, man?
Nothing much. It's going on. Life is as usual. Classes, right? And then I got my first shot. I don't know if I mentioned that, so that's good.
You got your first one.
Yeah.
Did you get sick?
Not really. A little bit of sore arm, so for a day. So yeah.
J&J or the M?
Moderna one.
There you go.
So,
all right, that's what I'm talking about. Sean, how are you doing from down under, man?
I'm doing good. It's starting to feel like fall weather down here. We're coming into fall on the other side of the world.
I am very jealous, but definitely going to have to make a trip down there very soon.
Sure.
Anyway, we have a really fun show for you all today. We're going to be talking about something that destroys cities and worlds even. Of course, I'm talking about the atomic bomb, the doomsday clock, as some could call it. And we're going to talk about the physics behind it, the scientists involved, and really what the atomic bomb does. Now, there's a famous quote. I'm not going to quote it verbatim, but this was by Albert Einstein. It's very well known. But if you don't know it, here it is. It's something to the effect where Albert Einstein says, okay, if we're using weapons in World War II like this, well, then I'm not sure what weapons we're going to use in World War III, but I do know that in the wars after, we're going to be fighting with sticks and stones. Very powerful message there, and it kind of makes you think that us as a civilization can kind of go down a few levels, right, Sean? What do you think?
Yeah. I think that's we all grew up. Well, I grew up hearing that quote and being scared of it. I grew up in the '80s. I was still a kid in the '80s when the Cold War was still going strong, and I remember one of my biggest fears when I was a kid. It's crazy to think. I don't think this is very common anymore. But one of my biggest fears was of a nuclear holocaust.
Yeah,
It was not out of the question. And honestly, it's still not out of the question. There's a lot of stuff going on geopolitically right now that, a nuclear war is still not out of the question. I think it's more likely it would be between the U.S. and China. But yeah, it's totally possible. And it's scary.
Well, it was very common for my parents, remember growing up with this turtle mascot. I think it was Bert the Turtle or something similar, where, duck and cover. Just in case a nuclear bomb comes, well, you know what? Hey, got to get under that desk and put your hands behind your head like that's going to help, right?
Yeah.
But, very, very scary. Now, let's before we really get into the science, because, Anirban, we're really relying on you for the science on how we extract this kind of power, unbridled power from the smallest thing we know, right? The atom. Let's start back in the Stone Age, right? So we started with the Stone Age. And, Sean, are there any animals right now that are in the Stone Age that you think?
Well, the Stone Age, it's interesting. These things move along like they do, but there are still hunter-gatherers that could be considered Stone Age people. When you move from one of these ages, and these are kind of antiquated terms that archaeologists don't really use anymore, but they're still kind of fun to talk about. But, Stone Age people, when you invent, bronze, every person on Earth doesn't immediately enter the Bronze Age. So there's kind of a time lag. So there's still hunter-gatherer people. There's still, there was a great National Geographic article maybe 10 years ago about the last cave people that were living in caves in New Guinea, and we're having a hard time, and we're starting to think about giving up that life and moving down and moving to a city. So like the end of the Stone Age may be well and truly kind of coming upon us. But yeah, here we are in the nuclear age, and people are still, there are still some people in the world who live a hunter-gatherer existence.
Interesting. So, okay, well, hey, they're still here, but now we have the Bronze Age, right? I mean, we realized these metals can slash things better than rock.
Right.
So we start forging, and we start crafting these tools that can basically, give us more resources that other people have gathered. So we start fighting with each other. And then after the Bronze Age, we have, the Iron Age?
Iron Age, yeah.
The Iron Age. I'm quoting Age of Empires, by the way. I mean, I love that game. If you ever played it, I highly recommend you play it. I love that game.
No, I haven't played the new ones, but I played a lot of the Age of Empires 2, so I know what you mean.
Oh, yeah, Age of Empires 2 is my game, too, man. But so after your Bronze Age, you get a better form of steel, a better technology, your Iron Age. And then you have more aerial kind of weapons with like bows and arrows and ballistas. You get the Romans, perfected warfare. You get even to some biological warfare by using the Black Death, the Black Plague. They would actually use catapults to launch
infected bodies.
Yeah, exactly. Infected bodies over into the castles, and boom, like they'd take out the whole population. And then we get to, gunpowder, right? Napoleonic Wars and everything like that. Wild West, the Wild Wild West. But this era that happened, do you remember what date we perfected this technology? Anyone?
You mean the first nuclear test, the Trinity test?
The Trinity test.
I just saw it because I was kind of doing some background research. I'm not going to remember it specifically, but
it was in
crazy.
the 40s, right?
It's July 19th, 1945.
Okay.
But I'm wrong. There's no way I'm right about that, but it was July 1945, which is crazy because we dropped the bomb on Japan a month later.
Wow.
As soon as we like tested it, okay, now send these things over there to blow them up. As soon as it was done. It's crazy. Yeah, the story behind this is a remarkable historical event. And I know a little bit about this. I was joking with you guys about it. I said I was an expert on this. I'm not, but I read an amazing book that I feel like everybody should read, called The Making of the Atomic Bomb by Richard Rhodes, which won the Pulitzer Prize for general nonfiction. And there's a good reason for it. It's really well written, and it's super interesting, and it's all about the Manhattan Project.
Oh, the Manhattan Project.
Yeah.
Very cool. Very cool. Well, yeah, let's go ahead and get into the scientists that actually made this happen.
Yeah, Anirban, who? I mean, there's a ton of them. So, do you have some key figures?
Well, let's set the scene, because you have Hitler and the Nazi Party. Just imagine if Hitler had the atomic bomb. Well, just imagine.
So that's one of the things. One of the key things I learned from reading this book, which I don't think is common knowledge, which should be, is that every major government involved in World War II was working on the bomb. Not just us.
Right.
Everybody. The Russians were. The Brits were. The Germans were. The Japanese were. It was a race. And kind of everybody knew it. Everybody knew it was a race. So all the kind of foundational physics that had been done to kind of theoretical physics that suggested that this was possible had already been done and was kind of out there and written for 10, 20 years. It had been hypothesized. In fact, one of the first people who kind of thought that this was possible was not Jules Verne, but what the hell's his name?
H.G. Wells?
War of the Worlds. H.G. Wells.
Yeah.
He wrote about nuclear bombs in like the 1910s and 20s, or even earlier. And he thought that what these things would do is they would blow up and they'd be these sustained chain reactions, and that these bombs would go off and continue to go off. So there'd be these big orbs of like explosions going on for like 10,000 years. which is kind of an interesting thought. But that's kind of what he thought a nuclear weapon would end up being like. But so all the physics gets worked out, and then every government on Earth knew that this was a possibility.
Yeah.
And really only we really put the effort into trying to get it. But everybody was working on it throughout World War II. But nobody put in the kind of dollars and effort that we did. And it's a damn thing we did.
Yeah.
Because if the war had gone on for another 5 years, and it probably would have if we hadn't come up with the bomb, the Germans could have gotten there first. And let me tell you, if they'd gotten there first, this would be a totally different planet.
Different planet. Yeah.
If the
100%.
Japanese, if the Imperial Japanese had gotten a hold of this first, it would be a completely different planet right now. And if our allies in World War II, the Russians, had gotten it first, we'd be living in a completely different world right now. It's a damn thing. It's a damn good thing.
I mean, if the Russians got it, like, it would be an actual socialist state than what people think what it is.
The Soviet Union would have taken over all of Europe.
Yeah.
I got here just in the nick of time.
There would have been nothing to stop them.
So Thomas is here.
We might be lucky enough that the United States might have been able to keep this facade of friendliness towards Russia, but certainly all of Europe would be under Russian rule right now, at the very least. And the Soviet Union would have been the only superpower left after World War II.
Do you think our trump card was that we accept scientists from all over the world, all different races, religions, creeds? Like we didn't care. We just want that technology. I mean, I believe Oppenheimer, whenever he
not
expressed
till 1960s.
What's that?
Not till 1960s. I mean, this is really not deviating from America really didn't have open border till 1960s, as you said. The ones that you're talking about are the scientists who are fleeing from the Nazi regime.
Yes.
That's more that's a different political thing. So there is a thing about accepting all changed after 1960s Immigration Act, and then you had more scientists from other places showing up. It's a little technically little different there. This is not a political show, but I'm just saying.
Yeah.
I'm just saying.
I think we're a little more welcoming than Hitler and the Soviet Union.
Yeah. I mean, in that regard, yeah, but it's not like things were. I'm just saying it's a little bit different. But going into that, what I was going to say about the scientist involved. So when Sean was saying that, we actually covered one of the scientists called Lise Meitner, who was going to get a Nobel Prize but didn't get because the selection committee involved wasn't working in her field to know the things. So you have Otto Hahn, who actually does the actual extraction of the nuclear material for the bomb, while on the other hand, Meitner is the one who does the theoretical calculation to purify and how to extract stuff. Mm-hmm. So that happens around 1938 to get that thing rolling.
Okay, well, let me share this with everybody because we're about to get into the cutting edge science that happened. But after the first test of the atomic bomb, then there was a reaction by every scientist in the room, and who better to kind of describe or illustrate with words this reaction than Robert Oppenheimer. Let's listen to it.
He knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.
Wow, that is
it's pretty chilling.
It's very chilling. But that the poetic religious text that he refers to, I mean, that just makes it even more powerful that this is the reality now. And in order to do this, we have about 5 more minutes in this first particular segment. First off, welcome, Dr. Thomas Shiller.
Howdy.
He transcended time and space.
Yeah, I had a dinosaur emergency I had to attend to.
A little defibrillator action going on a dinosaur. Okay, cool. No, but okay, so we have another 5 minutes left in this segment. Let's talk about the scientists involved in this, right? We had Einstein. We had Feynman. We had Oppenheimer.
Yeah.
And we had the one you were just talking about.
Yeah, they were not directly involved. They were still like, I think in Germany or in Europe or something. So I don't think they were directly involved, but they were like, they laid the scientific foundation. For example, Einstein was not directly involved in the Manhattan Project, and Sean can correct me. He was like one who said, we need the bomb.
That's right.
Yeah, and
so Einstein wasn't there like at Hanford refining uranium. He wasn't at Los Alamos, but he played a crucial role in our effort because he signed on to when the first scientists approached the Department of Defense people, the U.S. administration, trying to convince them that we needed to work on this. They got Einstein to sign off on that. And Einstein was very famous at the time. Nobody had ever heard of these other, scrubs who were kind of doing this, but everybody knew Einstein. He was like, the Neil deGrasse Tyson of the 1930s.
I mean,
40s.
this is Neil deGrasse Tyson without internet, without television or anything.
He was the face. He was the face of physics, face of science, and here he walks into like the administration offices, and they're saying, "Look, this is theoretically possible, and we need to get it first, or else it's our ass." And Einstein signs off on that. So he plays a crucial role in the American investment in this project. And we invested a ton of money and time into this project. And this is, Conley, what you were talking about is like, what was the difference between the U.S. and other countries? Like other countries did work on this, but we went all in. And partially this was because of Einstein.
Well,
Einstein helped convince the administration that this needed to happen.
So I was going to say, when you say the scope, the number of people involved were in 130,000 people were involved.
Yes,
in this
something like 60,000 people worked at Hanford, refining plutonium. Hundreds of thousands of people worked at Oak Ridge in Tennessee, refining uranium. All these people had no idea what they were doing,
and they were getting the test site ready in Alamogordo, by here.
Yeah.
So there was
the scientists at Los Alamos. That was a small number of people compared to the industrial scale refinement of the materials that they would need to use to make the first bombs.
Wow,
that was like an industrial scale project, where it was like huge numbers of people getting bussed back and forth, and none of these people even knew what they were working on. They just worked for the government.
Right.
They're getting,
And you have to make sure like that when you're extracting, suddenly you ramp up the production of uranium. Russians and British people were kind of like, you have to keep that secret. So this is like a huge thing going on.
And it's funny, there's an interesting story. The Germans had a kind of a parallel project going on where they were trying to refine heavy water.
Deuterium,
deuterium. They're trying to figure out a way. Their project was kind of focused on deuterium, and so they were getting industrial levels of that stuff. And you know what we did when we found out they were doing that? We went in there with commandos and blew up the factory
in Norway.
So. In Norway, In fact, it wasn't Americans who did it. We got the Norwegians to do it. Norwegian commandos went in there and blew the place up.
Wow.
And so it's funny, like, there's a reason why we won that war. And again, it's a good thing we did, because the Germans were not good people in that war. And we were kind of, I give America a lot of grief sometimes. I'm too critical. But when it comes to stuff like this, objectively, it's a good thing we won that war. Well, we were the benevolent democracy in that war.
At the same time, you talk about all this money and these funds and all this effort that we put into being first, right? Getting, the first grasp, the first feel of this technology. And then a few months, was it a month or a couple months later that we just ignited it? And that's due because if we didn't, then that would have all been a waste, right?
Well, that's a serious question.
We're about to go to a commercial break, but I'm prefacing our next segment on that.
Yeah, we should talk about that.
Okay, all right. We'll see you after the break. All right, everybody, we are back with the Science Nights. Dr. Thomas Shiller joining us right now, and Dr. Anirban Bhattacharjee also all the way from down under, Australia. We have Dr. Sean Graham. Now, before the break, I was talking about all the time, effort, the money, the most brilliant minds from all around the world, the best scientists. America put that as number one priority to figure out this puzzle, extracting immense power from the smallest thing that we know, the atom. And at the time, we were putting in so much money as Americans, right? Well, if we didn't use that technology, would there be a backlash? Would people say, "Oh, hey, you just wasted all this money"? Like, what are you doing?
It's probably not the big thing that they were considering when they were debating whether or not to drop the thing.
Well, there's a big debate, though, right?
Well, it wasn't about the money. That the American people would have never known that we spent any of that money. I mean, it was so secret.
Oh, really? I didn't know that.
The debate was whether or not it was ethical, and there was very few people that really thought, no, we shouldn't use it at the time. So the debate is largely like 2020 hindsight. People, why didn't you just drop it into Tokyo Bay? And there's this book, The Making of the Atomic Bomb, really does a good job of kind of putting you back in the time of 1945 and things that people never realize or don't really consider. We were carpet bombing Japan for a year.
Yeah. The fires.
Every city with fire for incendiary bombs. We had complete air superiority over Japan for months, and we were sending bombers over all their major cities, burning the place to a cinder. We were killing more people with conventional bombs than the two atomic bombs ever killed. Here's the thing that you learn from this book. The reason why we chose Hiroshima and Nagasaki, they were one of the few big industrial cities that we hadn't already damaged. That's why. Because if we dropped it on Tokyo, the thing was half destroyed anyway. And the Japanese were not going to surrender. So the next place we were going to go after Okinawa, which was a total disaster and horrifying, just destroyed civilians, Japanese people, American soldiers. The next place we were going to have to go was mainland Japan. It was going to take years. It was going to kill tens of thousands of Americans, Japanese, and civilians. And so we dropped those bombs on two cities and ended the war. And so that was why we did it. It wasn't because we wanted to light up two cities. We were already doing that.
So in order to describe what had happened when we actually dropped the bomb on those cities, right? I mean, there's a giant... Anirban, you can help me out with this. So first off, there's this giant flash that kind of blinds you in the eyes. And then afterwards, there is like an explosion or do people actually watch their hands just like come apart while they're evaporated in the bomb? I'm talking about the actual explosion itself. And then you have the fire that comes out from the bomb. Like to just watch the mushroom cloud happen it's scary, but it's also amazing at the same time.
I don't know about the bones and like the flesh and everything evaporating. So the flash is the light that is coming. So obviously you're going to see it immediately pretty much. And then you have the nuclear material that has been expelled, like the radioactive material that's coming out and all those energetic particles, depending on how light they are. So they will come and flood you flood towards you. You'll have that. And then you will have the rest of the material coming in, and you'll have the heat wave and following the shock wave. I don't know which one will come first. I think the shock wave, the air pressure wave will come first, then you'll have the heat wave. But I don't know what is the exact... How far do you have to be from a heat wave not to feel the temperature rise. I don't know. I don't know. I mean,
yeah, it depends.
It is not that as much. It is a much smaller radius compared to the the wave that you see coming towards you, and all those stuff. So yeah,
and those are the immediate effects. Not to mention the fallout and everything that follows after. You know, people who weren't immediately killed by the blast, there were still a lot of people who were killed in the following weeks and months.
Yeah, I mean, look at one of them, the scientist who pretty much worked on radioactivity, Marie Curie, right? And she did not die immediately. She died slowly, right? Because of the radiation coming out of it. And this thing also has similar stuff that'll come out of it. And even if you don't feel any immediate, like that kind of stuff, you'll have those particles coming through you and you'll get infected and you will die later.
Now, Hiroshima and Nagasaki are both places you can go and visit today, but how long did it take for that radioactive material to go away?
I mean, with the wind, it was gone pretty soon. I mean, it's not like...
it doesn't stick around for a long time.
Yeah, this is not a Chernobyl where it seeps into the ground and you still have the reactor in there with the stuff. So,
you still can't go visit Chernobyl.
Yeah, so it's still there.
Along with the four-headed deer and fish with tentacles and stuff like that.
Yeah,
that's a rumor, though. Well,
this is one of those things that I think is, it makes me wonder, because Chernobyl seems like a disaster, but they also, there is stuff living near Chernobyl now, and it's become almost like this little biological preserve, even though the things that are there aren't particularly healthy. And it makes me wonder whether or not, if we had a 1950s style nuclear war, if it was that limited, whether or not civilization could actually survive it. It would kill millions of people and destroy huge areas. And there would be areas where, people would be dying of cancer at remarkable rates for years, but life would go on. It's not pleasant to think about, not something we should go, oh, well, cool, we could survive a nuclear war, so we should totally have nuclear wars. But I do think that maybe the whole idea of a nuclear winter scenario and the end of civilization, the end of life on Earth, might be a little far-fetched.
Yeah. Yeah, it is kind of delving into science fiction a little bit,
But it's not far-fetched to think that our grandkids, or not grandkids, but great-great-great-grandkids can remember back to us, speaking through these little stones and, having the technology we can, because that can happen at any time. We can always be moved back a few notches in civilization.
Yeah, hopefully that doesn't happen.
It would change history for sure, and it would make make World War II look like child's play. But, I remember there's a great book, one of the first kind of nuclear war dystopias is this, what's it called? Alas, Babylon. You guys should read that if you haven't. It's about, it's one of the first nuclear war kind of scenarios. And people in Florida survive it. Everybody else is dead. But what ends up happening is developing nations in the tropics end up being the only places left where, civilization kind of carries on. So places like Brazil, Mexico, Indonesia more or less become the global superpowers, and the Northern Hemisphere is just bombed to the Stone Ages. And I could see something like that happening. I could see people outside of the main areas where the bombs drop doing, reasonably okay. Rates of cancer globally would probably skyrocket.
I've got a dumb biology genetics question for you, Sean.
Mm-hmm.
So if like a nuclear blast or being exposed to radiation can lead to mutation, is that heritable?
So if it were to affect the germline, mutations on the so there's two different kinds of body cells. Your somatic cells, your body cells, are like just the ordinary cells that are everywhere. And those can become cancer cells, if something happens to them. And that's what would happen, if you have tons of all this radioactive material around, it's just carcinogenic. And so it could cause all these skin cancers, can kill you outright pretty quickly. If it affects the sperm and egg cells, it could lead to generational changes, right? Those are the kind of mutations that are going to get inherited, passed on. Those are the ones that lead to evolution. So mutations can happen to any of your body cells, and the ones that happen to your normal body cells that aren't passed on can change you during your lifetime and can lead to, cancer. Changes that happen to your gonads could be inherited generationally.
Okay. So
And
like
either of those two things could happen after, fallout.
yeah, so like a prolonged nuclear winter could potentially
Change the
drive
way.
evolution.
Oh, definitely. And I think that we're seeing that in like the animals near Chernobyl. Like as long as they reproduce before those kind of abnormalities occur, life will go on. It'll be in a different way, and it's not something we necessarily want. But there are plants and animals living near Chernobyl and getting affected by it, and they are reproducing and they are pulling it off. It's not. We don't want that kind of world, but again, it's not necessarily the end of the world.
Mm-hmm.
And I was going to say, yeah, and then they evolve, and they are a different evolution. And you have on the tropical people, well, you have the normal people sitting there, right? And then the normal people wants to get robots to protect them, right? Because the other side is evolved into with weird powers, right?
Now
and
we're
then,
getting really into the sci-fi.
This sounds like something that you've read.
I just finished reading.
Are there vampires?
When
involved?
no. Yeah, I was going to ask that.
Yeah,
Vampire.
I just read House of X, Power of X, the release of the Marvel X-Men stuff. So yeah.
Oh, okay. All right. Well, okay. Now we have about 5 minutes left in this break here, or before the next break. Let's get into the science. How does this work? How did these scientists figure out, okay, there's an atom and it's spinning. We just need to change that spin a little bit.
It's not that spinning. So this is why Einstein's name comes so much in this thing, is because even though it's not involved, other than the letter, he also said E equals mc squared. So you get the mass and you can convert it into energy. So now people realize you can convert little chunks of matter into energy, and a little chunk of matter releases huge amount of energy. So as you can see, c is a big number because c is the velocity of light. So you can take a little bit of matter and produce a lot of energy.
Yeah.
So that leads us to now thinking, well, let's look in what kind of material does this stuff, produces energy. So that's how we came to know of radioactivity, of radium decaying into something else, radium basically losing, releasing one. How do I say it? Every atom has in itself like a nucleus which has a certain number of protons and a certain number of neutrons, and after some level, if you keep on increasing the number of protons, it kind of becomes not stable. So it wants to break down to the stable kind of relationship, because protons have a positive charge, and if you and this positive charge is repelled. So if you put a lot of them in a small space, they want to go out. So there is another thing called balances. There's a phenomena called strong force, which kind of overcomes them, keeps them stuck together. But after some time, you can't just keep on packing them. Universe has packed them using certain processes, but they want to release the extra protons in some fashion and come back to a stable state.
And that happens naturally.
That happens naturally.
Isotopes.
Yeah. So, like, for example, carbon-13, the dating, carbon-C14 dating, and all those kind of stuff. So, it's going... So, basically, this is happening naturally. And you know that when, let's say, atom X has 20 protons and is unstable, and it's going to release 15, and it's going to go down to 15, and it's going to release 5 protons. So what people found out, that when it releases that 5 protons, that 5 plus 15 is not equal to 20 anymore.
Right.
So then you have a little bit of discrepancy in mass, and that mass gets released as energy in that. And
it's a chain reaction that goes.
It's not like a chain reaction.
Not infinite, though.
No, you just have to keep on going till you are done with all those unstable atoms decaying into stable states, into going down from 20 to 15. all the 20 that needs
But
to
it's
be.
spontaneous.
It's spontaneous. It will happen.
So are two atomic bomb explosions exactly the same, or are they variant?
I mean, if you make it out of the same material, it's the same thing. I mean, the process
Oh,
is
it
the
will?
same.
Okay.
Yeah.
All right.
So if you make it out
And
of...
the part I think you're thinking of the chain reaction, Conley, is the way you get a big atomic explosion.
Yeah.
Is you have to get, if you just there's no element that if you just have one proton fling off of it, it releases so much energy, like one element, one atom releasing a proton. It's not gonna give you that. You have to have multiple multiple atoms flinging their protons off, causing additional protons to fling off, causing additional protons to fling off to get that fission chain reaction that causes the nuclear
explosion.
Yeah.
Okay. So big things come in small packages, therefore...
Yeah, it's like you have to get the big thing. You have to do it in a very small time. Yeah,
Sure.
Huge amount.
Is that why short people are so scrappy?
Yes, that is why Hitler happened.
Oh,
So,
man.
yeah.
Oh, gee.
Yeah.
I wasn't going Hitler, but okay.
Well, you
Now we
always
know.
go Hitler.
Now we go.
Let's go with Napoleon. Napoleon's a little
Napoleon,
scary.
hey.
So
It's a little more PG-13.
yes, people don't remember Napoleon well enough, I guess. So
Oh, I do.
okay.
No, I'm just kidding. Anyway.
So I was just going to say, towards the end, right? You have this decay and everything. So, what you will have in basic atom bomb is explode like a small amount of normal explosive, like a TNT kind of stuff, in a small space. And when that happens, you have kept this is called fissile material, which is going to be exploding in a small space. And when the explosion happens of the conventional TNT, so that like pushes all the fissile material, the uranium-235 in a small space, and the reaction speeds up.
Wow.
So yeah.
Yeah, that's amazing. All right. Well, hey, we're reaching our last segment, and we've talked a little bit about the science. Now let's talk about the future. And after the break, we're going to go over a little bit about what, hopefully this won't ever happen, but what is the evolution of the atomic bomb? So we're going to talk about that after this. Okay, so we started out this show by talking about Albert Einstein, his prediction that he doesn't know what kind of weapons we'll use in World War III, but we do know that the war after will use sticks and stones, right? So now, Science Nights, let's talk about the future of bombs. Some bombs we use nowadays and possible ones we could use in the future. What do you think? What do we use now?
Now we just send drones with little bombs to take people
Tiny,
out.
like very targeted.
Autonomous drones. Yeah, we did that just recently. Wasn't really in the news that much.
Wedding or something?
It wasn't a wedding this time.
Oh,
The many weddings.
Many
Classic.
weddings.
Yeah.
I
So,
was gonna say,
where we left off, we were talking about fission bombs, the very first ones. The only nuclear bombs that have ever been used in combat were fission bombs, and we soon after developed hydrogen fusion bombs, which are even more powerful, and I guess and kind of simpler to use and even more powerful, way more powerful. Those are the ones that could kill worlds if you use plenty of them. But yeah, they're still around, and I don't know what the future is, to be honest with you. Some people say that the fact that we have nuclear weapons has actually prevented some major wars.
oh
And
wow.
there might be some truth to that. I mean, there have been no major wars between any of the nuclear powers since any of them developed weapons.
Yeah, I guess the question
Been
is,
proxy wars, but no real ones. And so some people argue that they prevent wars, and I don't know.
well, it really gives ourselves a question: how well can we control ourselves, right?
Or the big question is how well can we control the erratics out there?
Yes.
Not the nations
Yes.
that are quote unquote peaceful and get along, but like North Korea and places like that
Yeah.
if they got their hands on a fusion bomb, could potentially destroy some nations.
Well, North Korea has nuclear weapons. They're in the nuclear club. They did it. they haven't used them on, and it's probably, people, they would easily say, I'm sure they would say, the only reason why we haven't been smoked off the map is because we got these things. And that's what Iran, that's why they're trying to do it. It's because they know that once you have them, there's Pakistan has them. There's a certain degree of, it's the same logic of we need more guns to keep the place safe. It's the same logic.
So it's like a good old traditional Mexican standoff.
Yeah, it is.
We're all pointing the guns at each other.
And here's the thing about Pakistan and India having it between them, they're both like over 1.6 or 1.7 billion people. And in a small space, and then you have China right there. So it's not a fun. It's not a fun place to think about nuclear wars.
No.
Yeah.
Well, concentration. I mean, being more concentrated is that. I mean, that's your downfall, really.
I mean, those three countries pretty much would account for that area. Would be like half of world's population. Close to. So yeah.
Yeah.
I want to refer back, if I could, real quick, to the another really cool thing I learned from the book. If I keep talking about this enough,
It's good. It's good. Keep going.
But another misconception is that, and you'll hear people talk about this all the time. Man, the scientists invented this thing, and they gave us this Pandora's box, and it's all the scientists' fault. In a way, okay, fine. Scientists came up with this, and again, if American scientists hadn't pulled this off, it would be a totally different place. But after the development of the bomb, scientists came together in an effort to change policy. Scientists took it upon themselves to say, hey, look, I don't know if you guys knew this or not, but we just changed the world. And it's up to us now. The world is different now. We dropped these bombs. The world's totally different. We need to all come together and work out a way to keep the genie in the box. And you know what the American and all the other governments in the world told them to do? Stick it.
I mean,
go back to your big old book learning.
Yeah, go back to your book learning. We'll handle it from here. So the policymakers, those people, the politicians, they didn't take that opportunity. And then now we've got what we've got today: the arms race, the space race, the whole thing.
I mean, one of the very interesting thing about that group was pretty much everyone involved in the project became a pacifist, and including Oppenheimer, who led the project, and everybody. Yeah. So they became this. But
they tried to do the right thing. They tried to get to
I mean, policy, you can say
nobody
that.
Listened to them.
Yeah, but then it's basically USSR wasn't going to listen to your pacifism, right?
No.
So it's kind of So you would need to have that, and so going back to the science of the fusion bombs or hydrogen bombs, as Sean was talking about, which are commonly known, is basically in order to get a hydrogen bomb going, you need to first explode an atom bomb, and then it will create enough pressure and everything to trigger the hydrogen bomb or the fusion bomb. So, that's why
a fission bomb required an explosive device to energy.
This is like a third stage.
Yeah, in the hydrogen bomb, you need an actual nuclear bomb, fission bomb, to create enough energy to cause hydrogen to glue itself together, to fuse.
Fuse, like there's also deuterium and all. Yeah.
Crazy.
Yeah, so
we're just like one step away from the Death Star.
Yeah,
it takes a bunch of fusion bombs that have to explode.
What can we do? What can we do to cause even a more massive explosion with fusion bombs?
I was going to say, they were saying, in the blast radius of the things, it killed 1 kilometer or 1 mile when they exploded the atom bomb in Hiroshima and Nagasaki. But with the hydrogen bomb or the fusion bomb, they would come too close to wiping everything out within 10-15 miles. One bomb will pretty much kill off everybody in that city. These, if you want to do that, but they're very hard to do. So in that regard, this is not like a scenario where you see in the movies, a dirty bomb, a small country. It's not. So to do this, you need to have a country.
Not even a place like North Korea or something like that, right?
Yeah. You would need a huge amount of
so basically, the fairly responsible yet pretty sinister states have these bombs, right?
Yeah.
Like, so Russia, we do, probably China. So not.
I mean,
you know,
India is
folks
supposed
that-
to has one too. So there are places which you will have, but yeah, I don't. Yeah, this requires huge infrastructure.
not
to
a
get it.
terrorist group. A terrorist group
yeah.
isn't going to get one of these.
And you know what's really terrifying is that all it takes is one decision from one person to start the chain reaction, which is gets you into culture and molecular, and it kind of brings it all together. That one person has the decision to press a button to make this all happen, the destroyer of worlds. And that kind of wraps up what we're talking about, right? Is there anything else y'all would like to close with?
We can get energy from those
Yeah.
material from the bombs.
Yeah,
You
that's
can
a good for the last 2 minutes.
Yeah, I mean, we can.
Oh, by the way, we can get really, really clean, efficient energy from
that.
material.
If you, yeah,
See y'all next time on the Science Side.
yeah. I mean, people do forget this entire.
That's one of our
thing.
last episodes ended like that.
Yeah, it's like-
nuclear power is really good.
Yeah,
The end.
Yeah, I mean, just like you do need to remember, like, in spite of people who are the research stuff, most of them was to get nuclear energy. It was not meant for the bomb. So are you saying there's a fine line between infinite prosperity and death? I mean, I'm saying, do you really think people, when they forget TNT, right? They always think of bomb or something like a dynamite. But dynamite, think about if there was no dynamite.
It
then-
opened up the West.
I
That's
mean,
how we got the
not
railroad.
just West, anywhere. Like if you want to get build an air like a a railroad or make a road. If you don't have dynamite, how long it's going to take?
Sure.
That's a very easy thing to think about. I mean, that's why how you use it is going.
Well, it's technology,
yeah,
right?
Yeah, it's
Right.
going to matter.
Yeah.
So I mean, we can take the entire material they have lying in the nuclear bomb, and we can have a nuclear
You
reactor.
can also
and-
rob a lot of trains, though. I'm just saying.
Yeah.
Yeah. Imagine
I
if
think-
Jesse James had nuclear technology.
Exactly.
Nuclear bullets.
Yeah. I think it's going to be fine. I think we've opened Pandora's box, but we're going to put it back in. We're going to be fine.
Yeah.
We're going to make it.
All right. Well, there we go. We'll see you next week on the next episode of the Science Nights, where we try to put Pandora back in the box. But I don't think that's going to happen.
Let's talk about Pandora.
We'll just realize that we are Pandora. So there we go. All right. See y'all next week. Thanks for listening to this episode of Science Nights in the Morning. Be sure and follow us on Patreon for exclusive gear and uncut episodes. Check out the latest science articles on our Facebook page and subscribe to us on YouTube and your favorite podcast listening app. You can also listen every Saturday at 10 a.m. Central Standard Time at BigBenRadio.com. And if you got a question, we'll join the discussion. Hit the hotline at 432-217-1983 and record your message. We couldn't do this without you, and thank you so much for listening each and every week. That's Science Nights in the Morning with a K, and we'll see you next time.